Hey guys, welcome back to the channel. So today in this video we would be solving this daily LeetCode challenge. So it is find the minimum area to cover all ones, and this is the first variant of this problem. So the problem statement says that we are given a 2D binary array grid and we have to find a rectangle with horizontal and vertical sides and such that it should have the smallest area, okay, and it should cover all the ones that are present in the grid, okay, and we have to return the minimum possible area of such rectangle. Okay, so let's see this first test case. So here we are given this grid as 0 1 0 and 1 0 1, and here we can see that to cover all the ones that are present in the grid we should consider this complete grid itself. So the area is 6 here, which is 3 into 2, that is the length of the horizontal side and vertical side. Okay, so now let's see the second example. Here it is given as 1 0 and 0 0. So we can see that this is the rectangle which covers all the ones, and since there is 0 at all the other places, then this is the only rectangle which covers all the ones that are present in this grid. So the area is 1 into 1, which is 1. So let's try to see how we can solve this. So now let's consider this example where we have this 2D grid, and here we have 3 ones in this grid, which is 1 in this part, then 1 in this part, then again 1 in this cell. So now the rectangle which contains all these ones can be formed as this. Okay, so we took these sides and this is the rectangle which contains all the ones. So there are multiple rectangles possible, like we can extend it towards here or maybe towards here. But since the area of the rectangle which is minimum in this case would be for this rectangle, so we consider this. Now let's try to make some observations here. So we can see that for a particular rectangle it should cover all the ones. Hence we have to stretch this rectangle towards the left till there are some ones present over this side, and similarly we have to stretch it in the right direction till we have some ones in this place and we will cover them, and then similarly for the top direction also we will extend it till we have some ones present in this direction, and again same for this bottom direction, which is we will extend it till we have some ones over here. So essentially what we are trying to do here is we are fixing our top side in the place where it will cover the first one. Okay, so it covers the first one. Then we are extending our bottom side till here is some one, or any of this boundary there is one. Similarly in any of this boundary there is one, and same we are extending towards the left till we have some last one which is present over here, like in any of this column, and similarly we are extending towards the right till we have some one present. Let's say there are 2 ones or any number of ones, but we want the boundary. Okay, and then once we fix these points we can just simply calculate the length, which is this length part and breadth part, so L into B, which will give our answer. Okay, so what we can do is we can maintain 4 pointers. First one is the left pointer which will point to this left boundary, then we have this right pointer which will point to this right boundary, and then we have the bottom pointer and we have the top pointer which will point to this bottom and top corner respectively. Then simply once we get this corner, what we can do is we can do R minus L minus 1, because what we will do is we will take this R and we have L over here, so we will subtract this part so that we can get this section which is covered by L and R. Okay, similarly we get one part here, let's say it is P1, and then the other part would be bottom minus top minus 1. So we will get this second part, and then simply the answer would be P1 into P2. Okay, so let's see how we can code this solution. So here we maintain the grid dimension, then we fix our top, bottom, left and right pointer. Now what we want to do is we want to extend our top pointer till the top part. So now let's say we have some matrix as this. Let's say this is an example matrix. Here it is 1. Okay. So now we want to fix the top part. So as we will move in the bottom direction in our grid, so we will initialize this with integer.max value, because as we are moving ahead, the row number is increasing and we want the first row where 1 is present, so that we will get the minimum value. Okay. Now here the bottom value is initialized to minimum value because we are moving downwards, and here we know that the values increases. Okay. So as we want this maximum part like in the down direction, hence we are setting it to minimum, so that for every one which is present in each of these rows, we will take this one if one is present in the downward direction. Okay. And we do the same for left and right pointers. And then later in this part, we just iterate over this grid, and if there is 1 in this element, then we keep track of our top, left, bottom and right pointers. So we update it as basically we are moving downwards. So the top would be minimum value of this ones, so that we will get the top part. And then for the bottom, as we are moving downwards, we will keep the maximum value as we go down. So it is the maximum part. And then similarly for left, if this is something like this, then as we are going in the right direction while iterating, we want the minimum part, so we took the minimum here. Similarly for right, as we are going in this direction, again we want the rightmost part, so we will get the maximum of this ones. And then for any of the pointer, we will check if the pointer is having the same value with which it was initialized, then this means that no one was found in the grid, hence we will simply return 0. Because if any of the one is present in the grid, then all of these pointers would point to this particular element. So simply it will have some area as 1. So now we know that no pointer with 1 was found, hence we return 0. Now at the end, we just return the right part minus L minus 1 into the bottom part minus top minus 1, so that we get our area which is covered by this rectangle. So the time complexity here would be simply n into m as we are traversing the grid, and then the space complexity would be simply constant because we are not keeping track in any other separate grid. Instead, we are just calculating in the same grid. So yeah. So thanks for watching and subscribe to the channel for more such videos.